So for our 8-hour refresher training this year, unfortunately we're going to be video based with all of that, and so we'll be completing that through success factors, and also we will have a couple of videos that'll be on the K drive that we'll want you to watch as well. It'll be a part of that. But with that, this year did want to create a video. Over the last few years we've had significant fires here at our facility, and wanted to address some of that. And obviously the most important part of that is prevention, making sure that we're practicing good housekeeping, and we're cleaning up areas where there could be a potential for fire or whatever that might be. The other part of it is making sure that we're all adequately trained in fire suppression. And so there'll be kind of three parts to this. There will be a section on fire extinguisher training, just kind of showing a simple example of using a fire extinguisher. And then there will be a section on using our plant hydrant systems, just kind of going through hooking up the hose, hooking up the nozzle, turning on the water. We really find out that this is probably one of the most important parts of fire suppression in the plant. A lot of times we can expel fire extinguishers and we can put CO2, but a lot of times it really comes down to putting water on to get rid of the ignition source and get rid of the heat, to be able to really put an end to a smoldering fire, or just smoldering conditions in material. And so with that, wanted to this section really just kind of focus on our CO2 system, and then we'll cover those other systems later. But did find out with some of the issues that we've had with some smoldering coal in our systems that really having a good knowledge of how our CO2 fire suppression system works is important. And so that's what this is for. And I've spent a considerable amount of time going through and kind of getting to know that system better myself, so that I can convey that here in this video. So we'll go to this PowerPoint, which will kind of go through how this system works and how it relates to us, and used for our coal suppression, or coal fire suppression. So those that are new at the plant, maybe they don't fully understand that with our coal system we do have a comprehensive CO2 system in place to help suppress fires that might arise in that system. And so going through this, just want to make sure I get down. Okay, here we go. Sorry about that. So our fire suppression system is really, you guys are probably aware, but underneath our coal bag house we have our CO2 tank, which is shown here in this print by the manufacturer of that system. It also shows our lines coming out, and in this particular arrangement, or this part of the system, which the system is really into two different parts, and I'll kind of go through both of those. But in this one, where we pull that from the bottom of the tank, the liquid CO2, and then it goes through a vaporizer. This vaporizer helps put it into more of a vapor state rather than a liquid state, and then that's actually put up into the system right here. So we can kind of see what our vaporizer looks like. This is our vaporizer that is just across from the tank. And that's what its purpose is to vaporize that liquid CO2 as it's delivered to the valving for those different systems. So then from the vaporizer it comes up and goes, splits between actually three systems. This print only really shows two, but there's actually three systems, and you'll see the coal mill system right here. And so if we were to have say I'll just put a scenario of an elevated temperatures in our surge bin, our coal surge bin. And so there's a thermocouple in the pant legs, and if it gets up to 240 degrees Fahrenheit, then CO2 would be delivered to this system and then up into the top of the surge bin. You'll notice that it only shows it going up into the top, and the reason for that is because this part does not exist anymore. In the original installation, there were nozzles into the pant legs, but what we found was that they did not do any good because we could not figure a way to keep them unplugged. They were always plugged with fine coal, and it just never worked out to be able to have them there, and so they were eventually removed from that system. So going back to this scenario, so if we get this temperature it gets up to 220 degrees Fahrenheit, then it automatically starts this system, and it will start injecting CO2 into the top of this surge bin. Now that will continue for 6 minutes before shutting off. Then once it's shut off, if the control room operator wants to reinitiate it and continue putting CO2 into that system, then he can do that. But the automatic portion of this only triggers that for 6 minutes and then shuts it off. And that's just to kind of give us better control. We've had some issues in the past where we've had some problems, like during a shutdown when nobody was really monitoring it, and we had a thermocouple issue that caused some issues in it. Anyway, it discharged CO2 into one of the systems here until the tank was empty, and we didn't want that to happen anymore, and that's why we put a limit on that of only 6 minutes. But that gives the operator a chance to hop back on, and if he feels like he needs to put more in there, he can. This also, the operator can just do that. If it doesn't get up to 220 degrees, but if the operator sees that he's got rising temperatures in his surge bin, then he can actually initiate this and start it and get CO2 flowing into the surge bin, and he can continue to do that as long as he feels like he needs to. The other part of this is the coal bag house. You'll notice that we're plumbed with CO2 into the bottom of that bag house, and if you're familiar with the hopper of that bag house, there are 4 thermocouples in the side of it, 2 on each side. Again, if any of these thermocouples get up to 220 degrees, then it will start the CO2 system and start injecting CO2 into that hopper, and it will act the same way as if it were in the surge bin. It will inject that for 6 minutes, and then it will shut off, and then if the operator feels like he wants to continue that, that's up to him to be able to continue to purge that with CO2. The other part of this is it's actually been plumbed as well with a line going to our coal mill, which actually goes into the duct feeding warm air into the bottom of the coal mill. So there's actually CO2 that goes into that, as well as that's teed off and actually goes to the coal inlet chute. So the coal that's feeding into the mill is also is teed off of that and also has CO2 going into that as well. So if you needed that, the operator could select the vaporizer, which would take CO2 up to these lines, and then these can be manually opened, and I can show you a picture of what that manual valve looks like. It's right here. It's the top set of valves that are set up on that system, and so you could open up this valve, and that would deliver CO2 back into the like I said, the duct going into the mill, as well as the chute where the coal goes in as well. So those are basically the systems. Now all of these can also be operated manually, just like that CO2 going into the mill. You'll notice that all these control valves have a bypass valve on them, a manual bypass valve. And so if need be, you could open these valves and you could deliver CO2 into these parts of the cold system without needing to necessarily have the control room do that. So that's an alternative way to be able to do that, is to use these manual valves that you see here to be able to do that as well. So the next part of this, and this kind of shows you, maybe just to kind of show you, you have the three different sections right here. This is for one of them, this is for the other, and then on top, this is the one we looked at that is for the cold mill itself. Now these all have a tag on them. They have a metal tag, like you see this one right here, this one down here, and it does tell you what each of these systems go to, each one of those. So if you're ever in question which one goes to which, you can read these tags and it'll tell you it's either the surge bin, the bag house, or the cold mill. So the other part of this system is a liquid CO2 system, and that actually goes into the upper part of the bag house. So if there were an issue where the temperature started to rise in the top of this bag house, then CO2 would be delivered in this line right here up into the upper portion where the bags are in the bag house. Now this is automatically done by two temperature sensors, and they are set at 225 degrees up here in the top of the bag house. So if either of those two temperature sensors got up to 225 degrees Fahrenheit, it would automatically start discharging CO2 into the system. This is all independently controlled outside of the plant controls. So this would just happen, and it would continue to fire into the top of that bag house. Keep in mind that if these ever do go off, you'll notice on this print that it shows horns up here. These horns will sound, and they've rarely ever sounded in the plant, but if this ever goes off automatically, as I've described right here, then this horn will sound. And so if you hear these horns go off, that means that there is CO2, liquid CO2 being injected into the top of that bag house. And so that's something to keep in mind on that system. This particular system, this liquid CO2, has no means for the operator in the control room to be able to do that. This is all managed independently through this control box that you see down here. Now there are other ways to discharge that in there manually, and those are shown right here. You look at these emergency switches, which can manually initiate the system that you see right here. Now those can be started, or buttons pushed, or levers thrown, and it will do the same thing. It will send liquid CO2 into the top of that bag house. So if we were to go through these, we can see that this first one shows that it's on the southwest side of the first platform, or the first level going up onto the structure of the cold bag house. So if you go from the ground level up that stairway up to the first level, over in the southwest corner, you'll see this push button sitting right there. Then the other one is on the opposite, or on the other corner, over on the southeast side, and you can see that push button right here. Now the way these are initiated is kind of like a fire extinguisher. You'll notice it's got the plastic tag on it holding the pin in place, just like a fire extinguisher does. Then you would pull that pin and then push the button, and that would initiate liquid CO2 going into the top of the bag house. So that's not something you would want to do if you had hot spots in the hopper necessarily, because you wouldn't want to be putting CO2 into the top of that bag house. You would probably just want the control room operator to do that, and they would just send that in through their by the controls in the control room to be able to do that. So that's the way that's initiated. Then there's another switch, and this switch is on the ground floor level, near the tank, near the CO2 tank. And so this one is, you can kind of see, here's the CO2 tank sitting here, and this is this switch. And if I click one more time, I can show you kind of a close-up of that switch. So if I needed, again, to get liquid CO2 into the top of the baghouse, I would pull this pin right here that, again, is held in by a plastic keeper, just like on a fire extinguisher. And then I would take this lever and I would pull it down. When I pull that down, that initiates it and sends CO2 up into the top of the baghouse. When I want to turn it off, I have to push that lever back up. And so that's another way to be able to get CO2, liquid CO2, into the top of the baghouse to suppress a potential fire that might be up there. So those are basically the two systems that are used with the CO2. You have the liquid system, and then the other system that I described earlier that is more the vaporized system. And that's how both of them work. I think it kind of simplifies how this whole system works, and hopefully that answers some of the questions that you guys might be having about how that system works. And I think it's a kind of a good reminder, something to go through on a regular basis to remind us. One thing just to kind of back up is if I initiate the liquid CO2 system into the top of the baghouse with the push button or the pull lever down here, these horns do not sound. They only sound when it's automatically being set off because of these temperature sensors up here. So hopefully that answers questions that you guys might have. Hopefully that's a good explanation of how that works. And you know, again, if anybody has any questions on how it works, or if you need any other insight, or if you have maybe something you found with it, but I think this is a pretty good explanation on how it works, and hopefully that answers some of the questions you guys might have, and helps us to be able to deploy CO2 as soon as we need to when we have a fire or something like that happen.
So as we had discussed, we're going to talk about a little bit concerning fire extinguishers and fire suppression. If you've had a chance to watch that video, which is fire extinguisher safety, you may have seen some of these same things, but I wanted to demonstrate it here at the plant, showing a regular fire extinguisher. So there's a few things we need to remember anytime we make the choice to fight a fire and to try to suppress a fire. The first thing is we need to make sure, do we have a means of exit? If we don't have a safe exit or an exit path out of there, we should not try to fight that fire. We should always try to make sure that we've got a means of exit before we get started. The other part is making sure we have help. Call on the radio, do whatever we need to do to make sure that we've got other people on their way. If the fire is too large, we want to make sure we get help. We want to get that help coming, and using a fire extinguisher a lot of times might not be the best answer. We might need to get other types of fire suppression involved to be able to do that. So think those things through anytime you're making that choice to fight a fire. Make sure you have a safe exit. Make sure that you've called for help. And if the fire's too large, get additional help coming immediately. So I'm going to just go through the use of a fire extinguisher really quick. What we use anytime we're fighting a fire is we use the acronym PASS anytime we use a fire extinguisher. What PASS stands for is first, pull the pin. Second, aim the nozzle. Third is squeeze the handle or the lever. And then fourth is sweep. So that's what PASS stands for, is pull the pin, aim the nozzle, squeeze the handle, and sweep at the fire. You want to always make sure anytime that you're using a fire extinguisher that you're sweeping at the base of the fire, not directly into it. Don't make the mistake too of getting too close to the fire to begin with. Then when you're sweeping, make sure you're going beyond the edges of the fire so that you don't just split the fire in two and then you run out of fire extinguisher and you have a difficult time now tackling two fires. So I'm going to go through that example. So here we've got a fire extinguisher, 5-pound fire extinguisher. As I said, the first thing we're going to do is pull the pin. So we pull the pin, we're going to pull the nozzle out, we're going to aim it, then we're going to squeeze at the base and then sweep. Then just keep sweeping back and forth until we've knocked down the fire. Make sure you put plenty of chemical on the fire to make sure that you put it out, that you smother it and suffocate it. If you stop, oftentimes it might start up again. So make sure that you spend a few seconds after it looks like the fire's got out and continue to expend that dry chemical on the fire. So that's the use of a fire extinguisher. So the next part I wanted to talk about was the use of our implant fire hydrant systems for really putting large amounts of water on fires. Using a fire extinguisher, a lot of times we really have a hard time putting enough on there to be able to suppress a fire, and it really requires that we put a lot of water on those types of fires. When we're looking at tire type fires, coal fires, some of those where there's a lot of fuel in there and it gets deep inside, and we really need to put a lot of water on top of them and soak them so that we really take the heat out and that we suffocate those fires. So we have these hydrants located around the plant. So I'm just going to kind of go through a quick use of these fire extinguishers. So when you open this cabinet, you'll notice that we've got hose. We've also got nozzles in here. And then we've also got a spanner wrench as well. We've changed all of our fittings to be 1.5 inches, and that's all we carry now is 1.5 inch fire hose. So we do not use any more 2.5. Hopefully that simplifies it for everybody. So we put a reducer on all the hydrants and then a red cap. That indicates that's the connection point on the hydrant. If it's tight like this one, you can use the spanner wrench to loosen it up and take that cap off. Once you get the cap off, then it's time to hook up the hose. These hoses should be wound up so that the female end is on the outside so that you can connect it. You can connect that 1.5 inch fitting onto the nozzle of the hydrant. If you need to tighten it, you can use the spanner wrench to tighten that up. Then it makes it a lot easier to unwind your hose and get it ready to hook up the nozzle. Once the hose is unwound, we'll hook up our nozzle to the male end of the fitting of the nozzle. Then we'll want to stretch this out. So at this point, we're ready to use it. Once we turn the hydrant on with the valve at the hydrant itself, We can turn this valve on to open it. Most of them should be somewhat like this. Once we get water here, then we can set how many, if it's like this one, we can set how many gallons we want it set for, and then we can turn that on, and then we can also set the fogging with the end nozzle. And so once you get this turned on full, then you can start to put water. Again, just like with the fire extinguisher, you don't want to be too close to it, but you want to be close enough that you're getting getting water on the fire, because that's obviously what we're trying to do, is put large amounts of water on a fire source or a heat source to try to cool that off to take away the ignition source. So this is really a great tool in helping us to suppress fires, hopefully with any of these methods of fire suppression, that we don't need to really use them very much. We want to be able to take care of a fire or not have fires, and that's through prevention. That's making sure that we're taking adequate steps to clean up, follow good housekeeping practices, make sure that we've got good systems in place to suppress fires if they do start, that might be automatic or whatever they might be. So hopefully this has been of value to you to go through this, to be able to see how these systems work, how we do suppress fires. But I think, again, the important message is that we want to prevent fires, and that's through our other practices that we take out here at the plant. So, thank you.